want to look at a special case of case 1. Z the functions of y, and y the functions of x. You can compute the z dx, and that will be equal to del f del x. Z is a function of two variables. So we're going to do the partial differential. We're going to get this one, f subscript s, which is del f del x, and we're going to compute this one also. Also, this one is a function of one variable, so that will give us the y dx. And then times this one is going to be, actually we don't have it, dx, we're going to have this plus del f del y times the y dx. Okay, and this one is 1. If you differentiate x with respect to x, that's 1. Okay, so and that will now give us this. Okay, and you can also write this one as what? As in subscripting notation. The two equations are the same. Okay, compute the z dx for z equal to x, natural logarithm xy plus y cubed, and y equal to cos x squared plus 1. In this case now, what we're going to do is simple. The z is a function of two variables. Okay, so in that case now, we can have del z del x. Here we can have del z del y. So let's quickly get those two values. The partial derivative of z respect to x is going to give us, in this case now, we have two functions, x and y. So when you are differentiating with respect to x, the other variable will be kept as a constant. I'm differentiating this one respect to x, that's 1. I'm keeping this one constant. That'll be ln of this function. Now keep your s constant now and differentiate the natural logarithm, and that will be equal to, don't forget, ln of f of x, the derivative of that, the derivative of the composite function all over the function itself. That is how to differentiate natural logarithm. So in that case now, we're taking this one constant, we are differentiating this one, and that will be equal to, we are differentiating del x of x, y. So in this case now, y is just a constant. Okay, so you are only differentiating the x, and that will give you what? That will give you y in that place. So that's y over x, y. So the whole of this place is what? Is equal to 1. So we now have here ln xy plus partial differential, okay, respect to x. Can we get the partial differential respect to y, which is del z del y. This is one's del z del x. So respect to y, what we are doing is that the s is constant. We are only differentiating the natural logarithm respect to y, and if you do that, x is what? X is constant. You're having del ln x y. So in that case now, it's going to give you the derivative of this one respect to y. This y is what you are differentiating respect to. So that's 1. You are keeping this one constant. So you have x over xy plus 3y squared. So this one and this one we cancel. So you have. So the next thing to do now is to compute this formula. That is the dz dx. Okay, and it's very simple. It's going to be, don't forget that the z is a function of x and y, and y alone is also a function of what? Of x. So the formula is going to, so we have the value for this. We're going to get this value now. Okay, and come back here, the y dx of this function of cosine is minus sine times 2x. So let's input what we have. The del z del x, we have the value for that which is this, and then plus the z, the y, times the y at the x, which is minus 2x sine s squared plus 1. Okay, so what we want to do now, we want to try to make it a single variable, and that will take us to x. My y is what? I'm going to substitute that. That's, and then plus 1 here times minus, that's okay, and then times this bracket here, plus times minus, that's minus, plus this parenthesis, this expression here, just brought it forward, and this bracket, write the content there. So we now have this, okay, then minus 2x sine s squared plus 1, in your brackets. My y is this, and then plus 3y squared. So my y is this, as 3 cos squared x squared plus 1. So close your brackets. So, and that will give us the z dx will be equal to ln of this. So when you open these brackets for this one here, so x times s, that will give us a minus 2x squared, and this is a sine, this is cos, sine over cos, that will be tan of that function. Okay, then minus times plus, that's a minus. Okay, then we have 2 times that 3, 6x, and then this times sine of this function, and then cos square x squared plus 1. So that's that on this. And what we did when we are here, we have two variables. We just try to make it a single variable, and then we plug in for y in our answer. Don't forget to smash the watermarks of this video and subscribe, so that anytime I upload, you get notified. Click on like button and begin to type your comments. Okay, finally, share the links of this video on all your social media platforms. Thank you for doing that.